I bring this video for how to calculate fire pump and jockey pump capacity in firefighting system. Kindly subscribe my channel offerinally. How to calculate fire pump and jockey pump capacity in firefighting system. 1. Fire pump, electrical driven/diesel driven. Use Elite Fire Program. In general, total pump head equals height from lowest point to the highest point plus friction due to pipes and fitting to the last point and working pressure of the sprinkler. Calculating pump GPM. To calculate pump GPM, two sizing methods are available, the standpipe method and the sprinkler area calculation. In a fully sprinklered structure with standpipes, NFPA 14, 2010 standard for the installation of standpipes and hose systems says that the first standpipe requires 500 GPM and each additional standpipe requires 250 GPM, up to a maximum of 1000 GPM. For example, a building with two standpipes would require a 750 GPM pump, 500 GPM for the first standpipe and 250 for the second, and a building with 5 standpipes would require a 1,000 GPM pump because that is the maximum allowed by NFPA 14. Note that the local code or the insurance carrier may require more than the maximum allowed by NFPA 14. Area calculations are more difficult. You need to know the sprinkler hazard classifications of the building and its contents to determine the design density, and the square footage, area of operation, of each hazard must be calculated. The 5 types of hazard classifications from NFPA 13, 2010 standard for the installation of sprinkler systems are: light hazard, low quantity of combustibles with low heat release, e.g., churches, hospitals, museums. Ordinary hazard 1, moderate quantity of combustibles with moderate heat release and 8-foot stockpiles, e.g., mechanical rooms, restaurant kitchens, laundry facilities. Ordinary hazard 2, moderate quantity of combustibles with moderate heat release and 12-foot stockpiles, e.g., stages, large library stack rooms, repair garages. Extra hazard 1, high quantity of combustibles with high heat release and no flammable or combustible liquids, e.g., aircraft hangars, sawmills. Extra hazard 2, high quantity of combustibles with high heat release and flammable and combustible liquids, e.g., plastics processing, flammable liquids spraying. Refer to NFPA 13 for a more thorough definition of the classifications. Once the hazards have been determined, you next take the most remote 1,500 square foot area of sprinkler operation and multiply it by the density found in NFPA 13. Then you must add the inside and outside hose stream demand to the area calculation. This information can be found in NFPA 13 table. Hose stream demand is the amount of water that must be added to the sprinkler system hydraulic calculation to fill the hoses as well as ensure enough supply to operate the sprinklers. Inside hoses are generally 1 to 1/2 inch standpipe hoses that may be connected to the sprinkler system for initial fire attack. For example, if you have a 40,000 square foot building that is all ordinary group 1, the calculation would be 1500 x 0.15, density, equals 225 plus 250, hose demand, equals 475 GPM total for the fire pump. If the structure has multiple hazards, the hazard with the highest GPM calculation dictates the pump size. Make sure you touch base with the insurance carrier for a particular project, as they may require higher square footage or density requirements, depending on the job. How to calculate jockey pump capacity in firefighting system. 2. Jockey pump. A jockey pump is an important component of firefighting system. Jockey pump or pressure maintenance pump is a small apparatus that works in conjunction with a fire pump as part of a fire protection sprinkler system. It is designed to keep the pressure elevated so that the main fire pump is prevented from running unless absolutely necessary. From time to time, unwanted pressure drop, small water leaks, or even temperature changes may fool the fire pump into starting when it is not necessary. A jockey pump is electric motor driven. It is controlled with a pressure switch in the main trunk. It will switch the pump on and off periodically to maintain trunk main pressure at high level. How to size capacity of a Jockey pump? I have browsed the answer to this question and I found several answers. My colleague who asked me the question also has his own answer. He thought the capacity of a Jockey pump should be about 5 to 10% of main fire pump. I also found the exactly similar answer. In this source, Jockey pump with the capacity of 5 to 10 GPM is usually acceptable. And at different source, for example in this source, the Jockey pump capacity is 1% of main pump capacity. So, which one is true? I think it will be better to refer NFPA, National Fire Protection Association. Based on NFPA 20-year of 1999 standard for the installation of stationary pumps for fire protection, pressure maintenance pumps, Jockey pumps, shall have rated capacities not less than any normal leakage rate. The pump shall have discharge pressure sufficient to maintain the desired fire protection system pressure. So, the first thing to do to size the capacity of a Jockey pump is to look at the system and to calculate normal leakage rate. Based on NFPA 24-year of 1995 standard for the installation of private fire service mains and their appurtenances, maximum leakage per 100 joints is 2 quarts per hour or 0.5 gallon per hour. The standard requires the water and the pressure to be replenished within 10 minutes. We also need to take into account net positive suction pressure available, effect of rise to shut off the system to prevent overpressure,